It's about 2 years for a commercial satellite, beginning with the satellite.
смысле рядом с тобой там?
Ну, все, пускай бежит.
А он вообще-то фото занимался.
Ну да.
Видно, потому что так отсвечивает солнце, что вообще... если вы так смотреть, а ему что надо поставить? Какой? Лазер, да?
Я вам говорю, там картинка низкая.
Там
Сейчас
низко.
не надо подключаться. Потом, если он дальше чуть выйдет.
Если ему не надо подключаться, он здесь, прямо здесь, конечно,
Готовность 30 минут. Внимание! Проводятся уклады расчета стартового комплекса. Продолжается набор стартовой готовности ракеты космического назначения. Управление пуском передаю первому. Пятый. Управление пуском принял. Первый. Готовность 30 минут. Первый.
Yep, I'm out of the garage.
Make a right-hand turn.
Uh-huh.
Go up to DuPont.
DuPont, yeah.
Okay, cross over and head north on Connecticut Avenue. Notice immediately you'll see
там. что-то не видно.
Что-то тепло. Пошел в футболке. Что-то жалко. Нет, вот
В 7 утра здесь возвращались, особенно 8, уже 10, 20 уже. Смотри. У нас, конечно, будет сезон, потому что когда на празднике мы всегда шумится, а у нас там через 4 секунды реакция вся будет. Видно, просто не
Первый. Работа на космическом аппарате. И заряд батареи космического аппарата проведены. Замечаний нет. Прибой. Согласный план принял. Первый. Прибой. Перейти на бортовое питание космического аппарата. Первый. Есть перейти на бортовое питание космического аппарата. Прибой.
Туда, пожалуйста. Вы о чем? Уважаемый. Эфир. Сейчас мы еще разберемся, как это действительно. Так, минуту.
Все прошло.
Нас надо ложить.
А я лечу.
Я все понимаю, но надо понять, в каком ракурсе кем это снимать.
На нем написано, что он начал.
Космический центр Хронича. Мы снимаем по заказу. Значит, с России по заказу нашего не вопрос. А разрешительные документы конечно. А? Да, разрешительные документы.
Влад, Рафаэл, можно? Рафаэл, подойди, пожалуйста.
Доклад снова принял. Первый.
Нет, мы снимаем контракт для американцев. У нас контракт сейчас идет эфир курс на Америку и Европу. Все. Сейчас еще ударит нас.
Hello, I'm Kirk Peischer, the president of ILS, International Launch Services, and I'd like to offer a warm welcome to all our viewers at EUTELSAT in Paris, France, Northrop Grumman Innovation Systems and Space Logistics in Dulles, Virginia, as well as all our colleagues and partners at Khrunichev and Moscow and around the world, as we continue to count down towards the launch of EUTELSAT 5 West B and Mission Extension Vehicle 1 spacecraft on board an ILS Proton from the Baikonur Cosmodrome. At this point in the countdown, we are not working any issues and are progressing nominally towards our launch. While the Proton has performed dual missions in the past, this launch marks a milestone for ILS, as this is the first dual launch of 2 Western commercial satellites on board an ILS Proton. The teams from EUTELSAT, Northrop Grumman Innovation Systems, Space Logistics, ILS, and Khrunichev have been working on the satellites, launch vehicle hardware, and the mission integration for many months, and I'd like to personally thank them all for the hard work that has led up to this day. So sit back, enjoy the broadcast, and as always, I'd like to say go Proton, go Breeze M, go EUTELSAT 5WB, and MEV-1.
Live from Pad 39 at the Baikonur Cosmodrome in Kazakhstan, you are watching coverage of the launch of the EUTELSAT 5 West B and the Space Logistics MEV-1 satellites aboard an ILS Proton launch vehicle.
The weather looks favorable in Baikonur. The most recent weather readings I've received show that the current conditions are partly cloudy skies with a liftoff temperature between 26 and 28 degrees Celsius, which is 79 to 82 degrees Fahrenheit. Ground winds are out of the south today at 3 to 6 meters per second, which is well below our ground level limits, and the upper level winds are within limits at all altitudes. So the weather is well within constraints, and currently we are go for launch on the EUTELSAT 5 West B MEV-1 mission.
Stay with us. The countdown to the launch of EUTELSAT 5 West B and the Space Logistics MEV-1 begins now. Hello, I'd like to welcome our viewers to the live coverage of today's ILS Proton launch of EUTELSAT 5 West B and MEV-1. I'm Jennifer Gladstone, your host. We are about 15 minutes to lift off. It's great to have a veteran of more than 60 launches, ILS Vice President of Programs and Operations and COO, John Palme, join me as co-host today. John, it's great to see you again.
It's great to be back.
All right, so how about a quick update on the pre-launch activities going on in Baikonur right now?
Well, everyone involved in this mission is very excited due to the unique opportunity, as Kirk mentioned, for ILS to work with two commercial satellite customers on a single launch of two satellites. ILS previously launched a commercial satellite on a dual launch with a Russian federal satellite, but this launch represents ILS's first dual launch of two commercial satellites. It has taken many months to get here, but now the mission teams are ready. They're in their places in the launch bunker, in the control rooms, ground stations, and communications throughout the globe. EUTELSAT 5 West B and Space Logistics MEV-1 await liftoff aboard the ILS Proton from Pad 39 in Launch Complex 200 at the Baikonur Cosmodrome. We were all thinking of the impressive amount of time and effort by ILS and our partners at EUTELSAT, Northrop Grumman Innovation Systems, Space Logistics, and Khrunichev. And from conception to design to manufacture and to launch and finally into commercial service, this is a large-scale operation which involves precision planning and detailed execution by the entire team. Now, let's take a look at the mission flight profile for EUTELSAT 5 West B and Space Logistics MEV-1. This is the Super Synchronous Transfer Orbit, or SSTO, mission flight profile for EUTELSAT 5 West B and Mission Extension Vehicle 1, otherwise known as MEV-1. The Proton M launch vehicle will utilize a 5-burn BRIES-M mission design and lift off from Pad 39 at the Baikonur Cosmodrome in Kazakhstan with the EUTELSAT 5 West B and MEV-1 satellites on board. At 191 feet, or 58.2 meters tall, the ILS Proton is a 3-stage rocket with a restartable upper stage. The Proton's first 3 stages propel the orbital unit, consisting of the BRIES-M upper stage, payload adapter system, the EUTELSAT 5 West B, and MEV-1 satellites into a suborbital trajectory during the first 10 minutes of the launch profile. After that, the BRIES-M takes the spacecraft through the parking, intermediate, transfer, and supersynchronous transfer orbits during the remaining 15 hours, 45 minutes of the mission. The liftoff phase begins with the ignition of the 6 powerful first stage engines that generate 2.4 million pounds of thrust at sea level. As the ILS Proton lifts off from its launch pad, it immediately executes a roll maneuver to align its pitch axis with the flight launch azimuth of 51.5 degrees as it travels in an east-northeast direction across Kazakhstan towards the Pacific Ocean. The first stage engines fire for about 2 minutes, during which time the ILS Proton experiences maximum dynamic pressure. Soon after that, the first stage separates from the second stage. As the second stage ignites, 540,000 pounds of thrust is generated for 3.5 minutes. After Stage 2 main engine shutdown, Stage 2 separates, allowing the third stage engine to fire and generate 131,000 pounds of thrust for another 4 minutes. Soon after third stage ignition, the payload fairing, consisting of 2 symmetrical payload fairing halves, separates and is jettisoned from the launch vehicle. Having traveled from Baikonur to eastern Russia at 51.5 degrees north latitude, Stage 3 separates from the orbital unit, which is now moving at about 7,300 meters per second, or 4.5 miles per second relative velocity, in a suborbital trajectory. At this point in the mission, the BRIES-M upper stage, which is designed to inject payloads into a variety of orbits, takes over. The first of 5 BRIES-M burns occurs about 1.5 minutes after the third stage separation. The purpose of this first BRIES-M burn is to achieve a low Earth circular parking orbit, 171 kilometers perigee and 174 kilometers apogee. The first burn spans from Siberia to Russia's east coast. 1.5 hours after the main engine cutoff of the first burn, or MEV-1, the second BRIES-M burn begins, placing the orbital unit into an elliptical orbit called the intermediate orbit. Perigees increase 294 kilometers and apogee to 6,000 kilometers, and inclination slightly reduced to 50.8 degrees. This nearly 20-minute burn spans from the North Pacific near Japan to the South Pacific northeast of New Zealand. In a 19.9-minute sequence, the third BRIES-M burn is executed, the Auxiliary Propellant Tank, or APT, is jettisoned, and the fourth BRIESM burn is completed, resulting in the elliptical transfer orbit. In the transfer orbit, the perigee is slightly increased to 475 kilometers. Inclination is reduced slightly to 50.1 degrees, but the apogee is greatly increased to a supersynchronous altitude of 65,000 kilometers. The third and fourth BRIESM burns take the two spacecraft from southwest China to southeast Australia. The BRIESM performs various attitude maneuvers during the coast phases between burns, allowing EUTELSAT 5 West B and MEV-1, as well as the BRIESM, to be exposed to the warming rays of the sun at pre-programmed solar illumination angles, designed to meet power and thermal requirements of both the two spacecraft as well as the upper stage. About 10.5 hours later, the orbital unit performs a large plane change maneuver, greatly decreasing inclination from 50.1 to 13.4 degrees during the fifth and final BRIESM burn. Apogee remains constant at 65,000 kilometers, and perigee increases considerably to over 12,000 kilometers. The fifth BRIESM burn lasts approximately 6 minutes. About 15 minutes after MECO 5, EUTELSAT 5 West B is separated from the BRIESM, having reached its targeted SSTO orbit near New Guinea. 6.5 minutes later, the BRIESM enters a brief reorientation phase, rotating the BRIESM for separation of the MEV-1 spacecraft. The total mission duration from launch to MEV-1 separation is 15 hours and 54 minutes.
We are now under 8.5 minutes to launch. EUTELSAT 5 West B, the first of our two spacecrafts to be delivered aboard an ILS Proton and BRIESM, is a Ku-band communications satellite to be located at 5 degrees west. 5 degrees west is a key video neighborhood addressing predominantly French, Italian, and Algerian markets. The new satellite will provide business continuity for these markets via a Ku-band payload of 35 equivalent transponders operating at 36 megahertz connected to 3 service areas. Switchable transponders will also increase commercial flexibility. EUTELSAT selected Airbus Defence and Space and Northrop Grumman to build the new satellite. Airbus Defence and Space built the satellite's payload, and the platform was manufactured by Northrop Grumman. Northrop Grumman Innovation Systems, also known by the acronym NGIS, is headquartered in Dulles, Virginia, and is the manufacturer of both the EUTELSAT 5 West B and MEV-1 satellites. Space Logistics, a wholly owned subsidiary of NGIS, will operate MEV-1 after launch and provide groundbreaking satellite life extension services. MEV-1 is the second of our 2 spacecrafts to be delivered aboard an ILS Proton and BRIESM. MEV-1 is designed to dock to client vehicles in geosynchronous orbit using existing client satellite features to provide attitude and orbit control at the combined vehicle stack. MEV-1 has the ability to dock and undock several times during its 15-year design life, allowing it to service multiple consumer satellites. Space Logistics' initial service using MEV-1 will extend the life of the EUTELSAT 901 satellite. Space Logistics is pioneering the future of space by demonstrating the fundamentals of satellite servicing with MEV-1.
Longtime ILS mission director Russ Pratula is in the underground launch bunker near Pad 39. And since he's hard at work during the final count, in my earpiece giving me live updates from Baikonur Communications Center is Judy Opp, our ILS program support manager. Hi, Judy. Good. All reports are that systems are go for launch. For our viewers, can you tell us where the various teams are right now?
All the critical folks are in their respective places, monitoring the health of the spacecraft. Chef and Russ are in their bunker waiting for the launch near Pad 39. I'm in the communications center giving real-time updates to you, and my mom is in the broadcast, watching the broadcast, and from her computer in Arizona.
Thanks, Judy.
But we're getting to the countdown, so go.
So stay safe and good luck. We'll see you.
Thank you.
I'll step aside and we're going to watch. And we have ignition. Engine ignition and liftoff of this ILS Proton launch vehicle with the EUTELSAT 5 West B and Space Logistics 1 MEV-1 satellites on board. Now, about 10 seconds after liftoff, the launch vehicle performs a roll maneuver to align the launch vehicle pitch axis with the planned northeasterly launch azimuth. Now, the vehicle will soon experience maximum dynamic pressure, or max Q. Now, this is when the aerodynamic forces on the vehicle have peaked. And for Proton, max Q occurs about 62 seconds after liftoff at a velocity of Mach 1.6. Now, visible condensation that appears to be a stream of smoke can often be observed when conditions are favorable. Just passing 50 seconds after launch. And you can see that condensation. Now, everything seems to be proceeding nominally as the vehicle ascends over the cosmodrome in a northeasterly direction into a planned suborbital trajectory along the route, which provides a parking orbit inclination of 51.6 degrees. Now, we're coming up on the first stage separation from the second stage. That's set to occur 2 minutes into flight. In order to provide a near constant acceleration, the second stage engines ignite prior to separation from the first stage. And on a clear day, launch site observers might actually be able to see a halo effect as the second stage engines ignite. And we have confirmation of ignition of the second stage and a good separation from the first stage. And we have confirmation that the planned level of thrust on all four second stage engines has been achieved. The second stage will operate for about 3 minutes and 26 seconds. Now, the next key mission milestone will be the separation of third stage from the second stage at L plus 5 minutes and 27 seconds. About 20 seconds into the third stage operation, the density of the atmosphere at that altitude is low enough that the spacecraft no longer needs the payload fairing protection, so the extra mass of the fairing can be safely jettisoned. As the mission proceeds, and as the launch vehicle travels from Kazakhstan into Russian territory, our viewers may notice some brief planned delays in our reporting of key mission milestones, as the telemetry has to be relayed through multiple ground stations and facilities.
The first burn of the BREEZAM upper stage is scheduled for completion about 16 minutes into flight. Our live coverage will conclude shortly afterwards with mission updates posted to the ILS website, Facebook, and Twitter pages thereafter. Considerable amounts of time and effort and resources go into the manufacturing and launch of a commercial satellite. Let's take a chronological look at the EUTELSAT 5 West B Space Logistics MEV-1's journey to launch.
The journey from concept to launch takes about 2 years for a commercial satellite, beginning with the satellite operator and the manufacturer's designs, then progressing to integration and launch. Each launch campaign begins with the arrivals of the spacecraft and the crew in Baikonur. The satellite arrives via the massive Antonov cargo jet at Yubileyny Airfield in Baikonur and is carefully offloaded from the Antonov's cargo bay and placed on a rail car. The spacecraft makes the 6-hour rail trip from Yubileyny Airfield to the launch processing facility in Baikonur in a thermally controlled environment. System tests and other operations to include fueling of the spacecraft are performed by the crew in the high bay. At this point, joint operations begin. The skilled, experienced teams work side by side to bring all the flight hardware together. In Hall 101 at the Baikonur Cosmodrome, the satellites are mated together into the BREEZAM restartable upper stage. They are then rotated horizontally to be encapsulated within the payload fairing. Joint testing accompanies each mating activity to verify proper functioning of the many components. From this point forward, the spacecraft, fairing, and upper stage are referred to as the ascent unit. The booster stages are mated to form the entire assembly of the Proton integrated launch vehicle in Hall 111. The integrated launch vehicle is then fueled at the BREEZAM fueling station. After BRIESM fueling, the rocket rolls to the launch pad. Slowly and carefully, the hydraulic erector moves the rocket from a horizontal to a vertical position to be placed in the mobile service tower. The mobile service tower moves in to provide services and accessibility to the launch vehicle and the spacecraft. As a tribute to Yuri Gagarin, the first man in space, Proton is rolled out to the launch pad at precisely 6:30 a.m.
The E5WB Space Logistics MEV-1 mission team is represented in this combined greeting from Baikonur by ILS Program Director Russ Prytula, Krunichev Program Director Pavel Pasegov, Vijay Thakur, EUTELSAT 5 West B Deputy Program Manager, and Craig Dobbs, NGIS Chief Architect.
2 years of work on the program passed rapidly, and as a result of this work, we're conducting this launch campaign.
We have been here for about 6 weeks now as we wrap up another exciting launch campaign. This one had extra challenges due to integrating 2 commercial spacecraft for the first time. But as we resolved a number of issues along the way, we felt an extra sense of accomplishment.
Working in the space industry means you work with a lot of dedicated, passionate and skilled professionals working together as a team. We've seen a lot of teamwork here since we arrived at Yubileyny Airport, with the spacecraft preparations, the stack with our MEV-1 co-passenger, and integration onto the Proton launch vehicle.
We are ready to go. MEV-1 is a spacecraft that is going to be Northrop Grumman's first docking attempt with a commercial vehicle in geo orbit. With that comes a lot of challenges, and I'd like to say thank you to all the teams in Goleta, Dulles, and San Diego for all their hard work getting us to this point.
I'd particularly like to thank Krunichev and ILS for their welcome, their support and their cooperation during this launch campaign over the past 6 weeks.
And I offer my sincere thanks to EUTELSAT, NGIS, and all the teams involved.
I would like to wish good luck to all of us.
Go Proton.
Go BRIESM.
Go E5WB and MEV-1.
So since I got the latest updates from Baikonur, and we have confirmation of stage 2-3 SEP and stage 3 engine start, as well as the payload fairing jettison. Now the payload fairing jettison occurs at a velocity of about 4,600 meters per second, or 2.9 miles per second, at an altitude of 138 kilometers. Our next major milestone happens in a few minutes, and that will be the separation of the Proton's third stage from the BRIESM upper stage.
Now let's take a look at one of the main payloads of the EUTELSAT 5 West B satellite, which provides service of the European Geostationary Navigation Overlay Service, or EGNOS. EGNOS is the first pan-European satellite navigation system. It augments GPS satellite navigation systems and makes it suitable for safety-critical applications such as flying aircraft or navigating ships through narrow channels. Let's watch a short video on this important service now.
EGNOS's satellites were launched, mission control centers, as well as a network of ranging integrity monitoring stations, or RIMS, were put in place. The number of RIMS has steadily grown, constantly increasing EGNOS's availability. Since the open signal was declared operational in 2009, and EGNOS was certified for use in aviation in 2011, with the first APV-1 procedure published for Pau in France the same year, hundreds of airports and heliports have become more accessible, even in bad weather, thanks to these newly published procedures. Since 2012, the correction signal can also be received via mobile phone using the EDAS service. In 2016, LPV-200 was declared operational, allowing new procedures with minima down to 200 feet. EGNOS is part of a global network of compatible augmentation systems. Hundreds of new procedures are planned for the coming years, and EGNOS will become available beyond Europe, and is not only being used in aviation, but also by farmers, surveyors, hikers, captains, and thousands of different applications. In terms of performance, combined with Galileo, it will reach unparalleled levels of accuracy in the coming years.
It has been a great pleasure for all of us at International Launch Services to have served with our colleague Bertrand Moncouquet these past years. Now, Bertrand recently retired from ILS, and we wanted to take a moment to thank him for his friendship and his service to the commercial launch industry, including his role as program director for this mission for the last 2 years. Bertrand originally went to Baikonur as a representative of a spacecraft manufacturer on a Proton launch, and after meeting her there and eventually marrying his lovely wife Olga, came to ILS to work some of our most difficult programs. I and all my colleagues at ILS wish Bertrand all the best in retirement, and I'm reminded of a quote from Henry David Thoreau which says, "Nothing makes the earth seem so spacious as to have friends at a distance. They make their latitudes and longitudes." To our friend Bertrand, we say thank you and wish you and Olga health and happiness in retirement. Since our last update, the third stage engine should have completed and separated, but I'm waiting for confirmation right now from Baikonur.
All right, John, thank you. The BREEZM upper stage is designed for injecting payloads into a variety of orbits, including low Earth, geosynchronous, and supersynchronous orbits. The main engine can be restarted up to 8 times during flight and allows precision injection of the spacecraft into the final target orbit. Now let's learn more about Proton's technology and its role in the EUTELSAT 5 West B Space Logistics MEV-1 mission.
Soon we will have stage 3 separation from the BREEZM. The orbital unit, or the spacecraft together with the adapter, separation system, and BREEZM, will be traveling at approximately 7,300 meters per second at the moment of separation, or more than 16,000 miles per hour. The BREEZM will ignite for its first burn about 1.5 minutes later and will last about 4.5 minutes. About 4 minutes after the first main engine cutoff, or MEV-1, the vehicle is scheduled to go out of range of our ground tracking stations. After about 70 minutes, we will reacquire the signal prior to the second burn of the BREEZM. Since our last update, I did get confirmation that the third stage has separated from the orbital unit, and the BREEZM is awaiting the start of the first of 5 main engine burns. Now, ILS uses direct injection into geosynchronous orbit, geosynchronous transfer orbit, or like today's mission, supersynchronous transfer orbits for our different mission profiles. Since the BREEZM is a restartable upper stage with an onboard battery that can support missions as long as 21 hours, we are very flexible and can optimize the target orbit based on the mass of the payload. For lighter spacecraft, we can inject the satellite directly into a circular orbit in the geobelt with an apogee and perigee of about 35,786 kilometers, using very little of the precious onboard satellite fuel to move the satellite into its final position above the Earth. Heavier satellites, however, use the elliptical GTO orbit that has an apogee at the geobelt altitude but has a perigee of just a few thousand kilometers. The customer uses the spacecraft onboard fuel to raise perigee, to circularize the geobelt, and then this is accounted for in the satellite propellant design budget. Like today's mission, though, we have the supersynchronous transfer orbit, which has a higher perigee of about 12,000 kilometers, but an apogee much higher than the geobelt. Why? Well, with an apogee and perigee that's much higher than a GTO mission, the fuel the satellite has to burn to achieve a circular geo-orbit is much lower due to lower effect of the Earth's gravity at those altitudes. The only downside of this mission, it's about 15 hours long, which means I get even less sleep.
Makes for a long day, doesn't it?
Absolutely.
All right, at this point in the mission, the BREEZM has separated from the Proton's third stage, and we're waiting for confirmation that the upper stage has started its main engine. So what can you tell us about the mission status?
So the mission is proceeding as planned. I just got confirmation that the main engine has started. Now, this Proton launch vehicle has completed the ascent, and the BREEZM is now taking over the delivery of EUTELSAT 5 West B and Space Logistics MEV-1 satellites to their planned separation points at the supersynchronous apogee of an altitude of 65,000 kilometers. And we're going to wait and see how the first engine burn completes today.
All right, John, thank you. And now here's ILS President Kirk Peischer to tell us more about ILS's long history with its customers, EUTELSAT and Northrop Grumman, and the continued strong relationship with Khrunichev.
As I mentioned earlier, the launch today will be a first for ILS on several fronts. While the Proton vehicle has already completed 3 missions this year, this represents the first ILS Proton mission of 2019, and also represents the first dual launch of 2 commercial satellites under the auspices of ILS. While Proton has launched dual satellites previously, this is the first time that both were contracted through ILS. EUTELSAT, the operator of 5 West B, is a longtime customer for ILS dating back over 18 years with a history of launches. Some, their most important spacecraft with ILS. With 8 previous Proton launches, They are truly one of our most valued customers. Having the trust and partnership of one of the leading satellite service companies in the world is truly gratifying. W5 West B, with a payload provided by Airbus Defence and Space and a platform manufactured by Northrop, will replace the EUTELSAT 5 West A satellite at 5 degrees west. Space Logistics, a wholly owned subsidiary of Northrop Grumman Innovation Systems, is the customer for the first mission extension vehicle, designated MEV-1. In-orbit satellite servicing has been dreamed about and discussed for decades, and today is a historic milestone with the actual launch of a commercial satellite specifically designed for that purpose. The technologies that have been developed by NGIS are truly groundbreaking and represent the possibility of extending the life of geosatellites for many years. Today's launch is just the first step, and ILS will be watching along with the rest of the world to see that dream of in-orbit servicing become a reality in the ensuing weeks. ILS and Khrunichev have been hard at work towards today's launch, but on other fronts as well. Mission success continues to be our #1 focus. Khrunichev has and continues to implement initiatives to continuously improve the quality and reliability of the Proton and BRIES-M. Recently, ILS hosted approximately 80 customers, space underwriters, and other participants to see these improvements firsthand at a quality review briefing and factory tour in July. While briefings and tours are valuable, ILS and Khrunichev know that the ultimate measure of quality and reliability is mission success. We continue to demonstrate that with a consecutive success string of 17 straight successful Proton missions since 2015, and a trending 5-year reliability that currently stands at 96%. I think these numbers speak to how dedicated our colleagues are at Khrunichev, focusing on building a foundation of mission success. Speaking of foundations, ILS is continuing to build upon its 25-year legacy and adapt its service offering to a changing market. From demonstrating Proton's robust capabilities to launch dual or multiple small, medium, or large spacecraft to a variety of orbits, to the advancement of continued development flights of the Angara 5 vehicle later this year, ILS is continuing to find innovative ways to compete in today's competitive market. Let's return now to the broadcast team as we update you on the progress of the mission.
All right, so John, what's the current status of our mission?
So we're now at the point in the mission where the BRIES-M upper stage has completed its first burn, and we do have confirmation of the main engine cutoff. 4 more BRIES-M burns for a total of 5 are planned before a spacecraft separation. Now, all telemetry reports that we've gotten so far confirm the mission is proceeding as planned, and the vehicle is moving along the planned flight path. So in summary, as we say, so far, so good.
Excellent. Now, I know that in addition to the Heritage Proton BRIES-M, ILS has other product offerings. Can you tell us a little bit about these?
Well, in addition to the Proton, ILS has the exclusive marketing rights for commercial launches of the Angara launch vehicle family. Currently, we're offering the Angara 1.2 for low Earth orbit missions out of the Plesetsk Cosmodrome in northern Russia. This version of Angara is perfectly suited for delivering sun-synchronous missions into low Earth orbit. Additionally, at the new Vostochny Cosmodrome in the Russian Far East, work is underway for construction of the Angara 5 launch pad and facilities, which will be used by ILS to launch international commercial spacecraft to the same orbits as Proton.
So, John, what will happen after the Proton completes its mission with respect to the satellites?
Well, after spacecraft separation, EUTELSAT and NGIS will take over operation of the satellites. Now, the 2 spacecraft will execute a series of planned operations, which include the solar array deployments, the reflector deployments, and a series of apogee engine and/or electric propulsion system firings. And these series of firings by the satellite will bring the orbit inclination down to 0 degrees, raise the perigee, and reduce apogee, resulting ultimately in a circular geostationary orbit over the equator. Each satellite will move to their assigned longitudinal locations in the geobelt to begin their missions. In the case of MEV-1, this will also include a variety of tests to prepare for their groundbreaking rendezvous with Intelsat 901.
Well, this is where our live coverage of the launch of the EUTELSAT 5 West B Space Logistics MEV-1 satellites concludes. Please continue to follow the progress of the launch on our website, ilslaunch.com, and go to the ILS Facebook and Twitter pages for regular mission updates. I'd like to thank John Palme for co-hosting with me again today. And from Baikonur, ILS Program Director Russ Prytula and Program Support Manager Judy Opp for mission updates from the Cosmodrome. Thanks to you both.
I'd also like to recognize the rest of the ILS team in Baikonur, and that includes Mission Manager Mike DeSalvo and Campaign Security Manager Chris DiGilio. Safe travels, all of you, on the way home.
So to all of the teams working on the EUTELSAT 5 West B Space Logistics MEV-1 mission and our partners and customers around the world, we thank you for watching along with us.